All right, eighth grade, we are talking today about solving equations with variables on both sides. So let's do a little vocab review real fast. An equation is two blank set equal to each other. So picture what you see on either sides of the equal sign, and on each side rather, we would see two different expressions. So an equation is two different expressions that are set equal to each other. So to solve an equation, that means we're going to find the value of the variable that makes the expressions equal, because that's what an equation is. It's two expressions set equal to each other. So when both expressions contain a like term, you must bring all of the like terms to the same side of the equation. And we talked about this with our foldable note, that you have to get all of your variables on one side and all of your constants on the other. So let's take a look at what this looks like with a couple examples. If we have 2x plus 6 equals 3x minus 1, then 2x and 3x are like terms, and 6 and 1 are my constants. So I need to get all of those collected together. So let's start by getting our variables together. I'm going to go ahead and add 3x to both sides so that all of my x terms will be on the left side of the equation. 2x plus 3x is 5x. I still have plus 6. And on the right side of my equation, negative 3x and positive 3x are additive inverses, so those cancel to 0, but I still have a minus 1. So now I'm going to get all my constants together by moving my 6. So I'm going to subtract 6. Whatever I do to one side, I have to do to the other. So I'm left with 5x equals negative 7. Final step to get x by itself is to divide both sides by 5. And I end up with x equals negative 6/5. Let's look at how to translate questions into equations. What is the value of x when the expression 6x minus 9 equals the expression 4x plus 3? So I'm going to take these two expressions, 6x minus 9, and set them equal to each other. So that equals 4x plus 3. Now I can get all of my variables on one side and all my constants on the other. So I'm going to start by subtracting 4x from both sides. And 6x minus 4x is 2x. I still have the minus 9 on the left side here. My 4x minus 4x is 0, but I still have a positive 3 on the right-hand side. So now, since I have my x terms on the left, I'm going to move my constants to the right. So I'm going to do the opposite of minus 9, which is plus 9. So I'm going to add 9 to both sides. And I get 2x equals 12. Now to isolate x, I need to undo this times 2. So I will divide 2, do the same thing to both sides, and I get x equals 6. Your turn. Why don't you check out 12x plus 7 equals negative 8 plus 13x. Take a second to pause the video. See if you can combine all your x terms on one side and your constants on the other. And then you can unpause and check out your answer. If you got x equals 15, you are good to go. Okay, let's check out a real-life word problem now and see how we can use that to help us solve this problem by setting expressions equal to each other. Suppose the temperature in your town is 21 degrees Fahrenheit and rising 1.5 degrees Fahrenheit every hour. Your friend lives far away and the temperature in his town is 28 degrees Fahrenheit and falling 2 degrees Fahrenheit every hour. In how many hours will the temperatures be equal? So our first step is to write an expression showing the temperature in your town. So let's take these words and turn them into expressions. So the starting temperature in our town is 21 degrees Fahrenheit. Plus, and we are going to have a rising temperature of 1.5 degrees times the number of hours. So I don't know how many hours are going to go by, and it's going to change. It's variable, so I'm going to use the letter H. Now for our friend's town, their temperature is starting at 28 degrees Fahrenheit, but then their degrees are falling 2 degrees every hour. So we're going to do minus 2 degrees times the number of hours, which will be H. Now that we have these two expressions, we can take the skill we've been working on and set these two expressions equal to each other, because we want to know in how many hours will the temperatures be equal. So I want this expression to be equal to the expression for the temperature in my town. So we have our two expressions set equal, and now we get all of our variables together. So I'm going to start by adding 2h to both sides. So on the left I have 21 plus 3.5h, and on the right hand side I have 28. Now I'm going to get my constants together, so I'm going to subtract 21 from both sides, and I'm left with 3.5h equals 7. And now to isolate h, I'm going to undo this multiplication. So I'm going to divide by 3.5 on both sides, because that will cancel to 1. And 7 divided by 3.5 is 2. Since h equals 2, that's answering for me in how many hours will the temperatures be equal. So the temperatures will be equal in 2 hours. Awesome job. All right, let's do one more here. Mizzou has a fan base of 14,000 and is increasing by 160 people every year. Go Tigers. KU has a fan base of 24,000 and it is decreasing by 200 people every year. In about how many years will the fan base be equal? So let's turn our words into an expression. So we know that 14,000 is our starting fan base, and we're increasing, so we're going to add and we're increasing by 160 people every year. I also know that KU has a fan base of 24,000, but their fan base is decreasing, so I'm going to subtract by 200 people every year. If I want to know when these two fan bases will be equal, I can put them equal to each other in an equation. Now I'm going to combine or collect like terms. Let's get our variables together. So I'm going to start by adding 200y to both sides. And you might notice that I am changing which side I start on in different equations. I always try to keep my variable positive. So I'm going to use inverse operations so that my variable will stay positive. So in this case, I don't want to subtract 160 from both sides because that's going to take me further into the negatives. So I would rather add 200y to both sides so that my y term can be positive. So over on the left-hand side, then I'm left with 14,000 plus 360y. And on the right-hand side, I have 24,000. My negative 2y and my positive 2y canceled to 0. So now to get my constants together, I'm going to subtract 14,000 from both sides. 14,000 minus 14,000 is 0, so I'm left with 360y on the left side. And 24,000 minus 14,000 is 10,000. So now to isolate y, I need to undo times 360. So the opposite of multiplying by 360 is to divide by 360. That cancels to 1, so I'm left with y. Now here I can cancel my final zeros, one little shortcut, and then I'm really dividing 1,000 by 36. And when I divide that out, I'm going to get a repeating decimal. So now when I come back to my question, I understand why they're asking in about how many years. So if I'm going to take 27.7 repeating and round that to the nearest year, I would say that in about 28 years, the fan base will be equal. Awesome work today, you guys. I think that you've got the hang of this, so let's start practicing this on your homework.